Hello everyone, and welcome back to NetMastery Zone channel. In this video we are going to speak about the IP routing, and like other video in this channel, first let's speak about this IP routing, and then we will go to the lab and configure and check this theory in this lab in practice. Okay, let's start our theory here. IP routing, I'm going to here speak about the static routing. As you know, we have different routing protocols, dynamic routing protocols, and of course they have their own details and characteristics, and it will not be possible to speak about all of that details in only one video. Because of that, I just decided to divide these videos to different video to speak about the IP routing. Let's here start first from the static. First of all, what is a routing? Routing is a process of selecting the path, and this selecting the path can be in the public transportation, in telephone system, and also in packet switching that now we are speaking about. And for example, if you want to go from point A to point B, in this case you have many options to select the path. Which path is best for you? Of course, the nearest path and the fastest path. And this process of selecting this path is routing. And in the, if we say about in the internet protocol or IP, the concept is same. Selecting the best path, the nearest path, and the fastest path is a job that a router do. And this routing process will done by the special piece of network hardware that called router. And let's first speak about the router. What is a router? I just have a brief here, but there is a complete video, this video here in the down, the name of the video, and also you can find that in the comment. It will speak, I just speak about the different type of the network devices and of course a router, but here in brief, a router is a piece of network hardware that works in layer 3. Working in layer 3 means work in the IP in IP part of the network. As you know that we have 7 different layer of OSI model, and this router is working, the router actually working in a layer 3, and router can connect two and more than 2 networks together, and the needs of router comes when you try to connect to different network together. If you have only one network, means only one IP address, then you don't need a router. You can connect all your computers to same range IP address and communicate between them without problem. But if you have different range of IP address, then of course the need of routers comes here, and you need to decide which type of router and which routing protocol you need to use. Let's get back here in the last slide. Here you can see, for example, if I want to ping from computer A to computer B, I have here 2 different paths, and the first path R1, R3, and R4, and the second path R1, R4, R5, and R1, R4, R2, and R5. In this case, this router actually will decide to select which path to transfer this packet from computer A to computer B. As you see that the top path is shorter, and the router may use this one to send the traffic, but in practice maybe the other path, this path in the bottom, may be faster because of using the robust router here, and then this router will decide to select which path to transfer this route here. And next, actually how a router works. A router uses an internal routing table, and this internal routing table, for example, if you connect 2 or more than 2 network to a router, In this case, the router will create a routing table of the connected route in the memory, and every time when it try to send a packet from source to destination, it just check the routing table and decide to send this route to the which path according to the routing table. And this routing table, the router works with the following way. When a router receive a packet, first it just open the packet and check the header. And what is actually first, what is a packet? Packet is a small unit of data that will be transferred to the inside the network, and this packet has a header and also has a data part. For example, if we're trying to send a ping, it will create a ping data and attach a header to that, and that header has information about the source and destination, the MAC address, the IP address, and some other information that will be attached to that header. And the router open that header and find the destination IP address, and according that destination IP address, and by using the internal routing table, it just decide to transfer this packet to which path. And this information in the let's go to the other slide, and this information in the routing table is can be static and can be dynamic. The static, actually the administrator is responsible to manually create this routing table inside the router to then according to that information, the router will know to route the packet inside the network. This as long as this information is available in the routing table and the administrator is manually manage that routing table, everything is okay, and the router will route the packets. But in dynamic routing protocols, this dynamic routing table will be created by the dynamic routing protocol. And of course, when our network grow and we have many different routes, the managing the routing table manually is not a easy job, and it's not recommended. And because of that, we just use the dynamic routing protocols to do this job manually, automatically for us. And of course, the dynamic routing protocol will select the best and fastest path and nearest path to the destination. It's I can say it's similar like Google Map. If you wants to go from point A to point B and using with Google Map, the Google Map will show you the best path, and selecting this path is according to the information that it has in the past, and also the current information about your driving condition. For example, you're driving fast or slow, and it will tell you that how long it takes to go from point A to point B. But using the dynamic routing protocols, of course, it's need the processing power of a router, and it's depend to the type of the network and the number of routes that you need to process in that router. And according that information, you can select the different model of the routers inside your network. As if you check that video, I say that I put the link in the comment. You can see that we have different routers, the ISR, ASR model, and each of these models it's suitable for certain condition of a network. For a large network, of course, you need more powerful routers, and for medium and a small size, maybe a smaller and cheaper router will be used. And let's speak about the main routing protocols here. The first one, I can say the IP, the Internet Protocol, and this is a specified source and destination of the each packet inside the network, and the router will inspect this IP header and decide to route the packet to which path to the destination. And the second one, we can say that the BGP, the border gateway routing protocol, and this BGP is a little bit complex because it works outside of AS, the autonomous system. And what is autonomous system? Autonomous system is one or more than one network, and it has its own border, and in the BGP is responsible to control the IP address inside to get out from this autonomous system or to get into the autonomous system. We will speak more about the BGP and also autonomous system in the future video, but here just let me tell you that the BGP is a border gateway routing protocol, and it will widely used inside the internet, because internet is a very large network, and it has many different IP address and many different borders of IP address. And the other protocols that it works inside the autonomous system, and inside the autonomous system means that when you configure EIGRP, for example, enhanced interior gateway routing protocol, and it's a Cisco protocol. It's just you can see this protocol inside the Cisco devices. This one is only working inside the autonomous system, and when you try to, for example, I cannot say actually to redistribute the route outside of autonomous system, but you just using one process number for EIGRP and also for OSPF, and if you change this process number, this EIGRP routing will not works, and you need to redistribute route between them. But here the EIGRP is another protocol, and it's I can say a simple and very good protocol for the small and medium size network. EIGRP will works very great in the Cisco router. The second one is the OSPF, the Open Shortest Path First. This protocol is mostly used in the other brand of the router. Of course, it is available also in the Cisco routers, but at all it's the protocol that's used to find the shortest path for the route inside the network. And then we have a RIP, but this one is now it's not used, and inside the network I haven't seen this in the modern network to use, but of course it's a protocol that also can be used to route a packet, and it will use the count the hop and find the shortest path, nearest path to send it out. And then the other one is and this is intermediate system to intermediate system, and also this one is used for the routing the information inside the internet actually. Okay guys, we just finished our theory, and now let's go to the configuration and try to configure this network, and just practice all that theory in the network. Actually, this is the exact same diagram that we had here. Just I add some interfaces IP address in the interface to make sure that during the configuration that we are doing everything correct, and also we understand better that how we should point a route to an interface. For that, let's try route configuration of route from router 1. In router 1, if we check show run section route, you can see that we don't have any routing here, and show IP route, any route configured manually here. And if I try to run this command, show IP route, now you can see that we have some entry inside the routing table. For example, for network 10, and this is 10.10.1.0/24. This is the network that actually our PC is connected now, and it's directly connected to Ethernet 0x2. Actually, the router just make a simple routing table, and it it add all this entry that is directly connected to itself to this routing table. For example, if we check this one, 192.168.1.0/24, this is a big subnet actually of the 192 network, and you can see that router 0 and router 4 is sorry, the IP0 and IP4 network is directly connected to this. The router, the network 0, you can see the network 0 is connected to Ethernet 0x1, this one, and the first IP address is 1 and the second IP address is 2, and also for the network 4, it's the first IP address is 5, that is configured here, and the 6 is configured in other side. This information actually comes from the router, and also from CDP or LLDP information, that when we connect two network devices together, they try to communicate and send and receive some information to each other to discover their directly connected interfaces. For example, if I try to ping 192.168.1.2, you can see that this sorry, it's 192. This ping should be successful, and it is successful here, but we don't have any entry for that because this interface is directly connected together. Then there is no need for any entry here. For now, let's try to start our configuration. Conft for configuring a route, let me tell you that we just tell to the router to get to a destination, it should select the which path, and it's in this manner. For example, I say IP route is a command, and when you are going to reach to the destination of 10.10.2.0, of course 0 because this is I'm going to use a /24 network here, and if I just select 11, just this PC will be routed, but any other PC may be in this network here. And with the subnet mask of 255.255.255.0, we need to go to which interface actually. Let's first configure this top interface here, and we have to send this packet to this interface. Now we are telling to the router, when you want to go to this network here, you need to send your packet to this IP address. It's 192.168.1.2. Make sure that when you configure this destination IP address that you are going to send your route should be accessible. If this not be accessible, the route will not get to the routing table. For example, let me remove this just to check. For example, I'm going to give this interface. This interface is not directly connected to this router, and if I use this interface as a next hop, and if I do show run section route, you can see this route is configured here, but this IP address is not accessible actually. If I ping it, do ping, you can see I cannot ping this IP address. It's not accessible because it's not directly connected to this router, and this router doesn't know anything about this route. And now if I check the routing table here in the do show IP route in this router, you can see that there is no route installed for this network to get to the destination. You can see we configured the static route here, but there is no static route actually in the routing table because this next hop is not accessible. If the next hop is not accessible, the router is not going to install that route inside the routing table. Okay, let's remove this and make it correct. Next hop 2, and do show run section route. You can see that now we have the route, and this route is pointed to a next hop, and this next hop is accessible. And if I use the command do show IP route here, you can see that this route is installed in the routing table here now as a static route with the flag of S. It means it's a static route and it is installed in the routing table because this interface now is accessible. Before that, the interface was not accessible and it was not any static route in the routing table. Then please make sure that when you configure a route, the next hop, every time you point your route to a next hop, that next hop should be accessible inside the that router. Okay, now this R1 know when it wants to send a packet to a PCB, it should send it to this interface. Now this interface, this router doesn't know anything about this network, again, because it's not directly connected to its interfaces. It's connected to another interface of another IP, another router. Then we need to configure this route to this one also. Then IP route, again, to get to the destination of 10.10.2.0 with 24-bit mask, you need to go to 192.168.1.10. Again 10. If we point it to this network here, it will not be installed in the routing table because this IP address is not accessible inside the R3. And now if we check do show IP route, you can see that we have a static route here, and because this interface is accessible, it say that to get to this network you can via this network is accessible. Okay, now router 3 is also configured, and if we try to ping from this PC to this PC, now this router knows to send the packet to this PC, and this PC knows that to send packet to R5. And when the router the packet get to the the R5 in this router, because this network it's directly connected to its interfaces, this router doesn't need to know to send the route to which interfaces, because this interface is directly connected to itself and it knows about that. Show IP route, you can see that this network 10.10.02 is directly connected to Ethernet 0x2, and now the route from this PC will come to this PC. Okay, when the route comes here, this PC of course try to reply back. When a ping packet comes to this router will reply back. The reply should go from one of this path. For example, now if we try to ping it, it will not be succeed because the packet of course will come to this PC. But when this PC wants to try to reply back, this router doesn't know and doesn't have any information about this network here. You can see there is no route installed here for this network of PCA. Let's configure that one also. Conft again IP route to get to the destination of 10.10.1.0 with 24-bit mask, 192.168 from which path? From this one, 1.9. The next hop, of course, this next hop is accessible in R5 because it's directly connected to that. Okay, now if do show IP route, you can see that we have a static route is installed now for this network, and it's accessible via this IP address. But route comes here, and this PC, this R3 again doesn't have any routing information about this network in its routing table. We can check that here. It's we already run this command, and you see that we have a static route, and this static route just shows the path for network 10.10.2.0, this network. It doesn't have any information in the routing table for this network. Then let's add that IP route to get to the destination 10.10.1.0 with the 24-bit mask. It should go through 192.168.1. Which one? This interface. We are in router 3, and next hop is our 1.1, this IP address, the next hop. And now if we check the routing table here, do show IP route, and you can see that we have a static entry here, and that is for the network 10.10.1, and it's accessible via 192.168.1.1, and that is this router. And when the route comes here, we saw this before in the routing table, this network actually is directly connected, and we should be able to ping it now from PCA to PCB. Let's try that. Ping 10.10.2.11. You can see that the ping is accessible, the succeed, and the route is accessible through this path. Now this PC is able to ping to this network, but we have a command here. I'm going to use the router to run that command, because this is a virtual PC, and it doesn't have a real behavior of a PC. I'm not going to use this, but I can do router 1 to trace this route, to make sure that this route is going through this path. First of all, let's try to ping this network here, this network 10 from router 1. 10.10.2.11. You can see that this route is not accessible, and why it's not accessible? We have the entry in the routing table, show IP route. This PC knows that when it sends a route, it should send it to this interface, and it's doing that. It's because when we send this traffic to this network, the router uses this interface as a source, and this interface is not accessible in R5. When it goes from this interface, of course this router knows about this source, it's accessible for him because it's directly connected, and it will forward it to this router. When it get to this router actually doesn't know anything about this interface, and because of that, when it tries to reply back, it doesn't know to send this information to which path, because it doesn't have a route for this. To solving this problem, make sure when you try to ping when you configure a static route and you're trying to ping from a router to a destination, you make sure that you use a correct source for that, because this router just knows to get to this network, to do network 10.10.1, it should go through this path. But if the ping comes from another network, from this IP address, and it comes to this router, this router doesn't know anything about this, and it doesn't have any information in this range, and because of that, it cannot reply back and then just drop the packet. To solve this problem, now let me ping it with the source of just the command source, and the source can be the interface. We can write this interface, or we can write this IP address. Let me try the interface 0/2. Now you can see that this ping is succeed, because now this router used this source, and when it sent it to this it reached to this router. This router knows about this source, and then reply to that source, reply back to that source. Okay, now let's trace this. We have another command, trace route actually log every path that this packet go through. For example, when I try to trace 10.10.2.11, of course we need to add the source here, source Ethernet 0/2 again, and I'm going to add another command here, the numeric. Numeric means that use this IP address as a numeric. This is IP address. it is not a host name. If we don't use the numeric here, this router trying to resolve this as a name, and it's going to access the DNS server and try to resolve this and then reply back, but we don't have any DNS servers configured here. Because of that, I'm just using this numeric command here to make sure that when this router try to trace this as a number, trace this IP, use it as a numeric, and it's only IP address. It doesn't need to resolve it in the DNS server. Okay, enter. You can see that we get to to the IP address 2, then to the IP address 10, and then to the PC. It means that this route, actually, this packet comes from this path to PCB, and we can see that path here. Okay, the one link actually is configured. Let's try to configure the other link also. Conf T. Now to get to the again, we have the same destination but different path. IP route 10.10.2.0 with the mask of 24-bit, and now this time I want to send it to from this path, and this path is 192.168.1.6, and the next hop. Of course, this next hop is accessible, and do show IP route. You can see that now I have two different paths for the same destination. For network 2, you can go through IP address 6 or IP address 2, IP address 6 or IP address 2. Now this route is installed in this table. Of course, router 4 needs to know about this network because it doesn't have any information about this. Let's go and configure this one. Conf T IP route to get to the destination of 10.10.2.0 with 24-bit mask. It should go 192.168.1.13. Now, of course, this when the packet comes here, it will forward it here. But let's think about the reply. When the router reply back here, this router doesn't have any information about this IP. Then let's configure that one also. 10.10.1 IP route 10.10.1.0 with 255.255.255.0 192.168 1 dot, of course, this IP address 5. Now if we check this show IP route, you can see that we have two routers installed here, one for network 1 and another one for network 2, and the next hop is here. Now let's go to our 2 and configure this one also. Enable conf T IP route 10.10.2.0 with 24-bit 192.168.1 dot. Of course, it should go through R2 to this interface, and that is 192.168.1.18. And also in reverse, when the route try to get back, now this router needs to have information about this network also. Then IP route 10.10.1.0, it should go through 192.168.1 dot, this R2, this 14. Show IP route. Now you can see that we have two static route here, one for network 1 and another one for network 2. Now let's go to R5 here and show run section route. You can see that R1 only have one entry, and that is this path. We need to add this path also for this route. Conf T IP route to get to the destination of 10.10.1.0 1.0 with 24-bit, it needs to go through 192.168.1.17, this one. Now if we check this routing table here, show IP route, you can see that we have two different routes installed here. It's one. Why? Show IP interface brief. Okay, everything is okay here. Our last command was conft 192.168.1.17, and if let me try to ping this. Is it accessible? Yes. Do show IP route. It should has a two. Yes, it has a two route that installed for one IP for one network. You can see 10.10.10 and 10.10.10, and it goes through two different paths. I think the subnet mask is wrong here. Let me see. Show run section route. Yeah, actually I used the wrong subnet mask here, and it's only route to the network 0. You can see it's a /24 here, /32. Let me remove this one and add it again. This is with the 24-bit mask. Show IP route. Yes, now you can see that for one network it's 10.10.10. We have two different paths to access. And now let's try to trace this route from R1. Again, trace 10.10.2.11, and it should be numeric, and with the source IP address of, we can say, this time I'm going to use this IP address as a source, 10.10.10.1. Now you can see we have a load balance here. One route, first it goes to R2 and then R6 in the first one, R6 R2, and second it will goes to R13 and R10 here. Okay, this one R6 and R2. It means that it send the packet this side and also in this side, and when it comes here it will send it to R10. In the next step it send to R10, and also from here it will send it to R13, and next time when it goes to R10, of course this router has the information and it will send it to the PC, but this one it's another hop and it will send it to R18. Now we have two different paths for this, and actually our video is going to become very long. Because of that, I'm just trying to finish this video, and in the next videos we'll speak more about this. But now you as administrator, you need to configure your router in such a way that, for example, this path is because it has only one hop, it is faster, and I want to use this path as a primary path and this one as a secondary. For that, let's configure this one also. Show run section route. If I check the route here, you can see we already have this route configured, and let's just edit this. I'm going to edit that and add a distance to this one. If I put a question mark, you can see we have an option here between 1 and 255, and that is the distance metric for this route. For example, for this I want to have a distance metric of 100, and for this route I'm going to add a distance metric of 200. Now this one is a smaller distance metric, and this path will be used as a primary path. Let's try that. Trace 10.10.2.11 numeric with the source IP address of 10.10.1.1. You can see this time when I trace it, it just used one path as a primary path, and if this path is down in any condition, then it will going to use this path as a secondary path. And we can do this configuration same in the R5. Show run section route and conf t. I'm going to access no, doesn't need to remove that, just going to give the some distance metric here, and this is 100 this path, and for this I'm going to add 200. And now from this PC, if I try to trace 10.10.1.11 numeric with the source IP address of E02, this time I just use the interface. You can see just use this path as a primary path. Okay, I just decided to do something here. Let's go to router 1 and try to shut down one of these interfaces. For example, let's shut down this one as a primary. Conf t interface is 0 by 1 and shut it down. Okay, now we have a route from this side, and if we check the routing table, show IP route, you can see that we still have a static route and it's from R6. But if I try to ping here 10.10.2.11 with source of E02, you can see that the ping is unsuccessful. That is why, because actually this router preferred this path to send traffic back. When the traffic comes from this path here to this PC and this will reply back, it comes to router 5, and router 5 has a distance of 100 from this side. Then it just transfer the route to this side, and it will come here and drop, and because of that the route will be dropped and it will be unsuccessful. As I said, that the administrator actually need to tune every step of this static routing. Now, for example, if this route is down, one of these interfaces down, this one, or any of these interfaces down, this router doesn't know about this interfaces if it's down. Then it will just transfer the route to this path and it will be dropped. Then the administrator, of course, need to do some tuning here. Let me do that. Do show run section route, and actually we can turn off this interface to make sure that this router doesn't install this path route to its routing table, or even we can change this distance. For example, I'm going to change this distance to 50. If I change that to 50, then when the route comes from this path, then this router will prefer this path and reply back. And if we this time we try to ping, we can see that our ping is successful. There is a lot of problem with the static routing, and because the routers are not aware about the condition of other routers, because of that they are just doing what they are programmed for manually, and they are sending the routes information to the paths that may not be available. Actually, routing it's good thing, static routing, because it's very fast, very easy to configure, but we have to make sure in some complex networks it will makes a lot of problem, and also it's very difficult to manage, and because of that the dynamic routings, of course, they will aware the routers from any condition, any changes inside the topology, and then the routing will be installed according to the changes in the topology. Okay guys, thank you for watching, and the next video we may configure something. We may speak about the dynamic routing protocols, and I will try to start them. Actually, we have some of these videos inside the channel, but I believe they are a little bit advanced. We can try that with actually very simple and basic. And then for those who are just entered to the networking and wants to learn the routing protocols, it will be more easy to learn that. Okay, let's finish our video here, and thank you for watching. Please don't forget to like, comment and subscribe, and please follow us in the YouTube channel Net Mastery Zone. Thank you for watching, and see you in the next video.